This is a demonstration of electromagnetic induction. On the left is a function generator that is producing a 5 million hertz or 5 megahertz signal. That signal is a sine wave at 1 volt, and you can see that here on this, which is an oscilloscope. I'll pause the real-time display and just let you see that you have a signal that is at maximum 1 volt, drops down to negative 1 volt, and then oscillates like that 5 million times every second. We're running that signal through this. This is a ferrite rod surrounded by 20 wraps of a very thin wire, and we're going to call that the primary coil. That primary coil has, again, a 5 megahertz signal running, sine wave running through it, and we're going to take this secondary coil. What this is 20 wraps around a piece of paper, and we are taking a second probe that represents the blue line right here on the scope. The yellow line again represents the primary, and what we're going to do is we're going to drop this right over the top of that coil, and what you'll notice, I'll pause the display, is a beautiful example of electromagnetic induction. What you'll see is the blue, the second probe, is actually picking up an electromagnetic field that's generated by the first one, and these two coils are not electrically connected. They're physically one over the top of the other, but they're not electrically connected, yet the primary induces a current in the secondary coil. That's induction. This is an amazing bit of physics that is used in transformers, wireless chargers, radios, induction stoves, AC motors, and generators, and it is just incredible. But a couple of things to notice. First, the height of the yellow line dropped a little bit. That's because there is a load, we call a load. It is actually, some of the energy is being transferred into this secondary coil, but they're almost the same height. So that is an example of a one-to-one coil or one-to-one transformer. What we're going to do now is take this off, and we're going to swap it for a second coil that has only 10 wraps around it. We'll take this one with 10 wraps, and we'll place this again over the primary. And what you will notice is that the load is less, so the yellow hasn't dropped quite so much, and the secondary has an electric current in it, but it is not as high as the primary. This is called a step-down transformer. You can see that because the secondary has half the number of turns, that it produces less, almost half of the current in the secondary. We can do the same thing in the opposite direction with this. This is a 40-turn secondary, and if we drop this over the top of our primary, you notice that the load is really high. We'll pause this again, but you'll notice that the blue actually has more current than the primary, and this is what we would call a step-up transformer. And this is a wonderful example of how transformers work and how electromagnetic induction works. Another interesting thing about induction is that you can change the phase of the induction. For example, if we go back to the first demonstration where we have the two waves synchronized, if we were to take this same secondary and flip it, You'll now notice that they're going, when one goes up, the other one goes down. We call this out of phase, and in this case, we call this out of phase 180 degrees because when this one is at its lowest point, this one is at its highest point. So that is a demonstration of electromagnetic induction.